Let me ask you a simple question. If I model a steel frame in STAAD, is the beam column connection pinned or rigid? Most engineers will confidently answer, it depends. But here is the truth. STAAD has already decided for you. And if you don't understand this, your bending moment, your connection design, and even your stability checks can completely go wrong. Today I'll show you why same beam under same load can show completely different bending moments just because of how the connection is modeled. This is not a software theory. This is real structural behavior. First, one very important rule. By default, STAAD assumes every beam column joint is rigid. This means unless you tell STAAD otherwise, it assumes moment transfer is allowed at the connection. STAAD does not know whether you will provide a shear connection or a moment connection on site. It only knows what you allow it to transfer. Let's start with a simple case. On the left hand side you can see a beam which is simply supported, and on the right hand side you can see a beam which is fixed support. The span of the beam is same, 12 meter. The loading on the beam is same, 4.5 kN per meter square. The only difference is the support condition. One is pin supported and another is fixed support. Let's compare the bending moment diagram for these beams. For the simply supported beam, you can see at the support the bending moment is 0 and maximum bending moment is at the mid span of the beam. But in the case of fixed support beam, you can see now moment appears at the support and the bending moment at the midspan reduces. This is because in first case, in case of simply support beam, rotation is allowed, that's why you can see zero bending moment at the support. But in the second case where rotation is not allowed at the supports, here bending moment develop. The moment is redistributed to the supports and to the member. Let's also see the deflection. You can see for a pin support, there is rotation allowed and deflection is properly visible with rotation of the support. But in fixed support, you can see as the support is fixed, rotation is not allowed to the support and the deflection is lesser. Now let's convert this beam into a frame. Let's add column. You can see below are two additional frames. One frame is pin supported and another frame is fixed support. To the same beam, we just added columns 8 meter in length. One side is pin supported and other side is fixed support. The connection between column and beam is assumed as a rigid connection by default by STAAD Pro. So all these four nodes will be rigidly connected. Let's look at the bending moment diagram. You can see for the simply support beam, the maximum bending moment is at the midspan, which is 81 kN meter. Now for the same beam but fixed support, the bending moment at the midspan reduces to 27 kN meter. Now in the case of frames, when the frame is pin supported, the bending moment at the midspan of the beam reduces to 43 kN meter. For the same case, for the same frame when it is fixed, the bending moment reduces to 40 kN meter. So you can see the difference between the bending moment diagrams and the values. So far we have seen 4 cases. All of them were stable. All of them had a clear load path. Now let me introduce the most misunderstood concept in STAAD, member releases. What is a release in STAAD? A release in STAAD means you are telling the software this member cannot transfer a particular force or moment. By default, two members are rigidly connected in STAAD. If you want the members to be connected, otherwise you have to assign releases. Any member has these 6 degrees of freedom. You have 3 forces in the member, Fx, Fy, Fz. You have 3 moments in the member, Mx, My, Mz. These are the local axes in any member. Along the length of the member you have x-axis. Along the major bending direction you have z-axis. Along the minor bending direction you have the y-axis. The force in x direction is called Fx, the tension or compression force. The force in y direction is called Fy, the shear force in y direction. Or you have Fz, the shear force in z direction. The moments in the member are as follows. Along the x-axis you have the moment mx, along the y-axis you have the moment my, and along the z-axis you have the moment mz. These moments are along the axis of rotation. So mx moment is your twisting moment, my and mz are your bending moment in major and minor directions. Let us see how these are applied in STAAD. You can see here I have added two additional frames. One frame is pin supported and another frame is fixed support. The only difference between the frame at the top and at the bottom is that in the bottom frames for the beams I have assigned releases. Now let us see how you can assign these releases. Go in specifications, click on beams, and for the start of the member and for the end of the member you can assign releases for the moment. I have released all the moment for these beams. If I double click on start, you can see at the start of the beams, both the beams, I have released all the moments mx, my, mz. Same for the second case. For the end of the beam, I have released mx, my, mz. Now let us check the results. Let us compare the bending moment diagram. You can see in the frames the bending moment diagram was distributed as the connection between column and beam is rigid connection. But now in the second example, I have assigned releases, and because of these releases, now the bending moment diagram is not distributed to the column. That is why you cannot see any bending moment in the column. Now let us concentrate on this example case number 5. Here you can see for the beam, the moment is released. So the moment will not be transferred to the column. Also the column is pin supported. That means this whole structure will be unstable. The moment will not be anyway transferred to the ground. Comparing with the next example of the fixed support, here you have the columns which are fixed support. Again in this case also the beam is released and that is why the moment is not transferred to the column, but the column act as a support and this structure will still be stable because the supports are fixed. The column in case number 6 will be similar to a simply supported beam supported on columns, but the case number 5 where it is pin supported, this will be an unstable structure and the whole structure will collapse because this will be just like a beam placed on columns which are pin supported and this will not be a stable structure. This case number 6 is not a frame, it is a beam supported by columns. That's why the bending moment diagram looks similar to a simply supported beam. Remember this, STAAD assumes every beam column joint is rigid by default. If you want a moment connection, do nothing in the model, but you must design and detail it in real life. If you want a shear connection, you must release the moment in the model. Otherwise, STAAD will still transfer it. Software doesn't know what you are building. If your modeling and detailing don't match, the structure doesn't care. It still will fail.